Yep.
Full
Hello.
meeting
Hi,
today.
Josh.
Nice to see you guys again.
Yep. Good. So what? How should we start? So we continue where we left off, or what? What do you want to do?
Well, we made a lot of progress last week with the like the config and the designs.
Mm-hmm.
So I think that's good enough for now. I'm not too sure. I prefer to like work on the code to get some things done and push it, so
Mm-hmm.
we can all work together, continue
Yeah.
afterwards. So I was working this morning on the SD card and the screen transitions. Yeah, try to finish that up today. Then we can probably start making issues in the GitHub project.
Mm-hmm.
Okay.
You want us to make the issues, or you make them first, and then we check them out, and then we comment on that? How do you want to do that?
I'm not too sure. I think we can like discuss some issues today in the meeting.
Okay.
Add them to the GitHub
Yeah.
I think
project.
Louis want to say something.
Well, wasn't too sure where to start next. So basically, I just went to the wiki and started capturing some of the design decisions that we had in that Miro drawing,
Mhm.
and and other stuff from previous discussions, and try to consolidate that into a specification. Some like some root document that we can use going forward to guide the coding. Obviously, it's not it's not like a specification like some military project where absolutely nothing has to be changed, but just sort of a place to keep track of our design decisions, so that we're not revisiting stuff like that all the time. And anyway, so that's in the wiki right now on GitHub. And so feel free to go in there and
Yeah, I will check later.
correct or plunk away or whatever. I suggest that we just keep the issues page for actual issues. Like, hey, this is a problem, we need to solve it, or here's an outstanding question that's not ready to go into the wiki or not ready to go into code, but we can just record it there as a specific action item, and that way we can keep keep the issues page, to real issues, keep the project page as well, right? All those software to-dos and so on to specific items. So anyway, that's what I started doing. Feel free to carry on and have fun with it, or suggest something else. I'm okay with that either way.
I like the approach.
Yeah.
I think that's a good. I mean, that makes it transparent for everybody.
Isn't the issue page connected to the project on
Yes.
GitHub?
Yeah.
Yes,
Yeah.
it is.
Right, okay.
Yeah.
So we keep those for the actual problems then, as well as the projects to do.
Or outstanding
Right.
questions, right? We just don't know, so it needs to be investigated.
And we can make another column too for the questions if we have to. I mean, that's flexible.
Sure.
Yeah, that's a good idea.
Yeah.
I guess then the goal is to make like the first actual working prototype version, and then work in issues like, okay, now we have to fix this and add this, etc.
Yeah.
All right.
And then you want to make the first prototype for core 1 or core 2 or both?
I think both.
Okay.
I'm not sure. What do you think?
Well, for the real, I was working on the real-time clock stuff this week, and just pulling that in, and there's just a bunch of if-defs in there, for the core 2, because the real-time clock doesn't exist in the core. So
yeah, that's okay. I think for the core, then we don't have real-time clock, and then we can't support too much like start logging or something like some things that we need the time for to create logs. we'll have to delay that, and then I don't know. I think it's okay then for the core one to have some more issues, and then we can always make issues on GitHub to add some better support or implement some workarounds ideas. So we can focus on the core 2 in the development, and then still support the core 1 as well in a minimal version or something.
Yeah,
because the core 2 will be for a production line.
Yeah.
Right?
Well, yeah,
because
because we still have the prototypes around.
Yeah, that's why. That's why we
Yeah,
still
right,
have, I have still some hardware for making the prototypes. So we're still about 14 left or something like that.
All right.
So
Yeah, I think supporting the core 1 is kind of important. I don't really want to change my Zen to the core 2 because I have to take out the sensors now.
I
Just don't want to risk it.
Okay.
I don't have backup sensors or anything, so yeah, that's.
yeah, that's
I think it's a small extra thing to also add support, but all right.
okay, good.
Any development updates from anyone?
I changed only the README page and the wiki. So, but there were small changes. So it was still set up for the Raku, but now it's all is Zen and the links are correct. So, and I
All right.
added people to the developing team that you can see. So, yeah.
Well then, I guess Joe, you're here. Thanks for joining. I think Rob asked you to join for some. What was it again? For the config or something?
Yeah, for the config and especially for the config setup we are thinking of to do. And in the Joe, did you have the chance to see the videos before, or you
No.
couldn't have time? Okay. Because basically we want to take the config from the Nano and then add another file to it. So
When you say the config, you mean the config files?
Oh, the SD card. Yes, the SD card safecast.txt.
Okay, I don't think there should be a way to extend it without adding another file.
Yeah, it's not backwards compatible will not work, I think.
Okay.
So I've seen issues already with adding an extra line in there. So then it was you need to remake the whole code because I think it's 1024 bits maximum. And then it overruns it and then it cannot read it and a lot of troubles. I've seen that.
Well, there's no reason you have to be compatible. Just make a different file. Why have the safecast? Why have the same file?
That's what we do. Yeah.
I mean,
yeah. Okay.
Just use a different file name. Yeah. Use
We got SafeZen.txt.
Yeah, we have SafeZen. We have SafeZen.txt anyway for a special setup for the Zen.
Right. The only thing you have to be compatible with is the log file. Just has to be acceptable.
Yes.
Not the config file.
Yeah.
Okay.
I mean, the config file from all the other bGeigie's doesn't work in the Nano and vice versa. So there's no reason this one unit has to have a compatibility across the config files.
Okay.
I mean, I would recommend that if you make a new file that you use similar parameters in a similar paradigm.
Yes.
But that's just for my ease of memory.
No, that's for everybody. I think for other people too, not only for you, but everybody will.
I mean, come on, the config file is pretty obscure anyway. I'm not sure that's even that well documented.
No, we try to find out, but in the code you can find something how it's being used. So that is
and there are config parameters that aren't used, that aren't in the default file we distribute, that are legacies in the bGeigie Nano code. Things we use occasionally, and things that were left hooks for, but were never implemented, like the post office routines. I think those were never implemented. Have you got anything like that in the Zen code?
No, not yet.
Okay.
So because the code is basically completely new, it's different.
Have you? So you didn't. So it's a complete fresh start. You didn't drag any subroutines from the Nano.
I think some parts we took from the yellow knows the best.
Well, some functions like
Functions
the
only.
Geiger counter, or like the actual counting or the
The
connections with the hardware.
the binning and the way the counts are.
Yeah, and also the dead time, this function we took over and the things.
Yeah, the
small
dead
things
time
like-
correction has been controversial all along, and there has to be a. I don't know. We probably need to discuss that again. But we've been discussing it for a decade now, and there's no real resolution.
I see.
Right. Yeah, when
Rob,
we got the
Jay has
calculations
a very
in,
strong opinion about it, and doesn't agree with the way we did it in the Nano. So I think the RAD notes are doing something different in that regard.
Yes, they do.
I don't know. It's something. It's kind of esoteric and really only applies in pretty extreme circumstances anyway. So I haven't put a lot of worry on it. I haven't thought about it a lot. I mean, thought about it a lot. I don't consider it all that critical.
No, but for example, if we have a function generator and we generate exactly so many CPM, and when the display doesn't show it, it was like, that's probably the dead time was doing that, the dead time calculation.
Yeah.
Yeah. We figured out that
That's yep. And the fact that everything else we profess is the raw data, and the raw data should be unprocessed only based on real pulses. So yeah, the dead time correction has always been a controversy that way. And it basically something we inherited from the Medcom inspector and pre-digital devices.
Okay, that makes sense. Now we know the history of it. So
Right.
important.
So if you remember, the Medcom inspector had a connector on the side for a pulse generator to go in for calibration validation. That was actually a legal requirement in the U.S. going back to the 1950s from pre-digital devices, where you had to have a way to validate them with a pulse generator, and it doesn't make sense in digital devices, and I don't think the requirement is still around, because some of the newer devices like the Onyx, they don't have it. So
okay, good.
We don't have springs and integrators and things anymore. How are you, Rob? How are you doing on validation? Any thought yet?
No thought yet.
Okay, not far enough along.
No, but basically we have the same tube, so that makes it quite simple, and it's all digital. I mean, the safe pulse is the most let's say critical part of it. If we're using iRobot,
actually, the safe pulse changes the whole idea of bGeigieZ, because one of the fundamental design issues on all the bGeigieZ up to now, using either the inspector or the iRover, was the consistency from unit to unit, and we haven't been able to achieve that with the safe pulse. So that means we need to deal with the unit to unit calibration issues, and where we always just used a standard number before. I think all the devices that use the safe pulse are going to have a calibration factor in their config file, and it's going to have to be derived, and each unit will actually have to be individually calibrated, unless we can somehow get the safe pulse to be as reliable and as consistent unit to unit as the iRover was.
Okay, that's very important.
We've always had a calibration factor, but we've always just set it the same in every device, because they were so consistent to be within much closer than the uncertainty factors. But the safe pulse so far has not been so reliable, and I really don't know why.
Okay, thanks for the feedback. That's very helpful for us.
So we need the things that were in the Nano for individual calibration and And probably the features that were in the Nano need to be replicated, which isn't a problem, but it only had a fixed correction factor. It'd probably be better if we made a 2-point calibration factor so that we had a 0 offset and a scale, not just a scale factor.
The number, yes, I agree.
And maybe even 3 factors so we can make a curve instead of a linear compensation.
Yeah, I prefer that 3 factor for that. Yeah.
It'll be much harder to defend academically, but if we send units to laboratories and they match the calibration better, then probably that'll be the best defense of the algorithm.
That's true. No. Which calibration center do you recommend that we send them to?
Where to calibrate it?
Yeah.
Well, most of them will probably have to create a self-calibration, a way to do it, because it's a bGeigieZen, so people have to be able to do it without sending it to a laboratory. But for prototypes, I can't remember the lab we used in. There's one in California. That would be, a good place. I don't know how we'll get that funded. Talk to Peter about it. But at some point, at least 2 devices are going to have to go to a laboratory. I have sources to do simple calibration. They're in Japan, and I'm not. But I have sources here also, but not calibrated sources like in Japan.
Okay. No, that's also good to know. Before we send it to a laboratory, we prefer that you have a look at them. And then
of course, we want to be able to do informal calibration and validation on each design ourselves. But at some point before it becomes before ASBE is standing at a IAEA conference or something, then we're gonna have to have had at least some academic support for the design and the changes.
Okay.
To prove that it counts and that it's compatible. I know eventually for all the previous designs, I eventually put them on the SafeCast car and drove them in high spots around Fukushima. In fact, I even had at one point I had a classic, mini, and a nano all on the car at the same time. So that gave us the ability to verify that they all got the same readings in the same situation, and that all of the data collected by them is comparable. So we should do something like that, at least putting a nano and a Zen on some vehicle and go through areas that are higher than typical. So have to actually find hotspots in Fukushima or something. Or maybe I'll take one to Ukraine. I don't know.
Yeah, that's a good idea. You're going there?
Even Fukushima, it's getting hard to find areas that are high enough to actually give a confidence that it'll work in a disaster situation again.
Okay.
I mean, unless you can take it inside Daiichi, which I suppose is not impossible.
Okay.
Rob, have you spoken to ASBE recently?
Yes, but we could talk about it other time. Why?
I'm just wondering if he's aware of the Zen development and what's going on.
Yes, he joined us one time, so he knows what we're working on. I don't know if he's followed it, but he's aware. Peter, nothing. Okay. He's busy with many other things. I invited him many times personally and in the channel, but no, he doesn't want to join yet.
Okay. Any specific questions for me?
So this was the most important part, I think. I mean, if other people have other questions, please go ahead, because Joe. Now Joe is here, so we should take advantage of that.
Yeah. Well, Joe, hi, it's Louis here. I'm just working on the code. I was trying to pull together a specification, and I'm just wondering if we could could get you to either debrief with me just to have an idea. I'm going to start also looking at the nano code, but just so we sort of nail down exactly what the procedure is for counting the bins, for for dealing with CPM, whether or not we have that dead time correction. Also have Rob and I have a little Arduino pulse generator, so we can generate precisely timed pulses of the right pulse width and the right frequency. Obviously, it's just a linear. It's just a fixed. There's no statistics. There's no what's that called? The Poisson distribution or anything going on there.
Well, can you add that to the generator to have it have a?
I just now have to figure out statistics and probability and statistics, and that hurts my brain.
No, but
I took a course in electrical engineering a long time ago, and it was like, oh my god, I passed.
No, but I think I have some code for that. I've seen a prototype from Peter that had the code inside, a pulse generator.
Cool.
So I can have to look up. I'm not sure if I still have it, but I've seen the code. It was not that complex. There was some special formula that generate distribution.
Right.
Okay. Yeah, and it doesn't have to be a true, bell curve. If you just let's say you want 1 kilohertz, you run a 600 and a 400 hertz generator and let them interfere. So that's better than nothing. If you want to get better, then you do 3. You do one at 200, one at 300, and one at 500. That creates a lot of the artifacts, and it gives a better test than just a 1 kilohertz frequency. And eventually you can take that to an extreme where you've got 24 all simultaneously running timers, and then you get missed pulses, even because some are going to coincide. It's there's lots of ways to do it.
Okay, that sounds like a project. Thanks.
It is a project.
So, but still, what I could do is start looking at the nano code and the stuff that was previously done for the Zen, and try to kind of reverse engineering it, sort of make a statement of what it is and what it should be. And if I could get to review that would be absolutely wonderful. Absolutely.
There's some definitions in the way the bins were derived, and there's some caveats that have to be included when you count a bin and clear a bin, or switching between bins. You have to make sure you don't drop pulses. A pulse doesn't wind up in 2 bins. So in order to keep the counts accurate, for whatever definition of, actually what we're doing is working on the definition of accuracy. So that's not difficult.
Okay, fantastic. Sorry, just notes.
Yeah, and you're using the same terminology. We say CPM and CP5S. So CP5S is basically a single bin.
Okay, so it's accumulated over 5 seconds. Is that what?
Yes.
Okay, so single bin.
And then the CPM is just the most recent 12 CP5S bins.
We currently have 1 second bins. So because, well, it was an idea of Rob and me to have like update the screen every second with the past 5 seconds. So
right,
basically five bins.
So you're keeping 6. So is the CPM based on 60 bins?
Yeah, 60 bins.
Yes.
Okay, so then we'll just call that CPS.
Yeah, we have CPS, but we still, I think the 5 seconds gives a maybe better idea of the past 5 seconds.
The log file has to contain the CP5S data, but you can
Right.
get that by just summing the previous 5 CPS bins.
That's what we do, yeah. But the thing is, we want to update the screen every second with the last 5 seconds data. So it still works.
Having a 1 second update to the screen has been normal. we've always updated the screen every second, but what
No,
happens is
no, Joe, you're wrong. Every 5 seconds. You see
no, the
Nano
data
every
changes
5
every
seconds.
5 seconds.
Yes, it's always been 5 seconds.
Yeah,
That's
but
why
that's
we
the
need a
data.
spec.
The data is 5-second groups, but I think we update the screen every second.
No,
It just doesn't change.
no. The screen is not updated. You just need a code for it. The
Okay.
SSD 1306 code. It's every 5 seconds. It sends the data to it. The screen. I mean, we want to see the data every second if we have to. So it's maybe
Okay.
not the radiation count, but the other things. That's why we have one.
I'm actually more familiar with the mini code. So, and the nano code was derived from that, but added a display. The whole display was an afterthought and an option that became the center of the nano.
Of course, because it's very important.
So my question then is, can the display, just based on this foregoing discussion, can the display be something slightly different than what actually goes into the log file? So the log file, the data has to be exactly as specified, backward compatible with the Nano and other devices.
The display can be whatever you want it to be, and doesn't have to be compatible with other devices.
Okay, good. So that way we can have an update every second.
Yeah.
Or based on
and
the
there
last.
are already discrepancies between the display on the Nano and its log file.
Right.
That's true. Yeah.
Okay.
I think if you currently in the Zen code, we have the CPS, which is the per second CP5S, then we have CPM raw, which is like the actual pulses that were measured, and then we have the compensated for the metcom dead time, which is the CPM comp.
Oh, okay. So CPM
we,
raw is actual counts, including the physical limitations of the sensor.
Yes.
Yeah. Okay.
That's just what we read in the on the pin, basically.
And which do you write to the log file? CPM raw or CPM comp?
We are currently not writing to a log file yet. So, but it would be either of those, depending on what we should be writing. So,
right.
I mean,
that's the difficult discussion, because it's the one we've never been able to resolve. Absolutely. And my answer to it has always been, hey, below, like 6 microsieverts an hour, it's the same. The value is the same. And it takes a long time. It takes a pretty high rate before the difference between those two values gets to be more than 1. So at all normal conditions in the world, the difference between those two numbers is 0. And then at places in Fukushima, places where the radiation is high, maybe in an airplane at altitude, then you start to get a difference where the difference is 1. When it gets to be 2, then I actually start to think about it, and that's such a rare condition that we just keep kicking that down the road, say, well, we'll solve that problem next year, or we'll solve that problem later. And in fact, we may never solve it, and I'm okay with that.
Okay. By the way, we have about 5 minutes left on this recording.
Okay.
Okay. Any more questions or things? I'm not sure if we need to continue on the Miro designs and setting discussions, except for what we've already done today.
No, for me, we can stop after this meeting. I mean, that's fine, because we still have to. We can work on the code. I mean, that's fine.
Right.
That's good.
That's what I'm aiming for. So.
Yeah. Yeah, that's good.
So nothing
So
else?
Louis, did you get your questions answered? Do you have anything more?
Enough at the moment that I just need to dig into this so I could ask more detailed questions and get an understanding of it myself. So I'm not even sure I quite understand your answers, because I just know so little about it. So
okay,
just to be honest.
Well, I'm not a coder, but I have the background in the physics. So
perfect.
Yeah. Okay. And Michael and Josh, you're fine for next week? Let's to have things enough to do.
Yep.
Yep.
I'm gonna be looking for issues and stuff in the code.
Okay. Good. And if there's any problems, just drop or questions, drop in the channel for everybody so we can see.
I'm not up to date on Slack, including this channel. I've been doing other things this year.
Yeah, we know.
That's okay.
I'm happy that
problem.
you could make it, to get your involved. Very useful feedback.
Well, you do the same time every week?
Yeah.
Okay, 5 a.m. Sunday. I think I can do it. I mean, it's completely dark outside, but okay.
You're also dark and on the screen too, so.
That's because there's no real light in this room, so.
I see. Okay.
And other people are asleep, so I don't want to be in the main room. So.
Okay, I can imagine. Okay, I think then we can close it, the meeting. We all agree, or something
Yeah.
else?
Fine by me.
Sounds like a plan.
Okay.
Okay, have a good week.
Oh, that's
good
better.
one.
Now we see Joe.
There he is.
Okay,
Yeah.
have a good weekend. Okay.
Okay.
Bye.
Bye-bye.
Bye.
Right.